So in today's lab, we will be covering levels of central tendency. So we're going to be looking at um, ways in which we can learn more descriptive information about our variables that we're interested in the database here. So in particular, we're starting off with a nominal variable, so something that's categorical. So she would like you to start kind of looking at some descriptors of gender. So in the last tutorial, we kind of touched upon this a little bit about what type of descriptive information that we can derive from categorical variables. And what we can really only look at is kind of frequency as a level of central tendency, or mode, which kind of goes with frequency. So what category is the most frequent in the database. And then we'll also be looking at the other two measures of central tendency, such as mean and median, which we can use for variables that are more on the scale level. And then we will also be looking at measures of dispersion. So this is kind of when we're interested to look at where do people lie in terms of the mean. So how much do they vary from the mean? And the range of scores that that are on a specific variable. Are people scoring on the really low end all the way up to the really high end? Or is there a very specific smaller range that people are scoring in? And then standard deviation, which is the actual amount of units that people are dispersed in, that they vary from the mean. Okay, so this will become a lot more concrete as we kind of start working with SPSS and kind of interpreting the information based on the variable that we're working with. And lastly, we're going to be looking at skewness and kurtosis. So what this really has to do with is looking at the dispersion of the data over a normal curve. So we're looking for kind of people that are scoring on a certain variable that might be abnormal. So we might see kind of some people who are very different than the mean and throwing off our nice normal curve. Or we might see that a lot of people are scoring really low or really high on some of our variables, which causes kind of a skewness, whether it's positive or negative, and we'll look more into that. And also kind of the range of scores are going to affect kurtosis. So kind of is everyone scoring around the same amount so that, it's our normal curve is very flat, so everyone's scoring around the same latitude of that. And so these are kind of important indicators to know if our data is normal or not, and then kind of make a judgment call on who is scoring abnormally and what does it mean if some of our variables are skewed negatively or positively in how we interpret kind of our data. So first we're going to start off with something very, very basic. So we're going to start off looking at our variable gender, which is nominal. So all we can really derive information from this variable is kind of getting SPSS to count the two categories and to give us kind of a frequency of to describe the percent of people who are male or female in this database, or look at kind of what is the most frequent gender in this database. So we can also use mode as kind of a level of central tendency that could be useful to describe the data in terms of gender. So I would also advise that you have a Word document open, because we will also be kind of copying and pasting most of the things that we're doing in this lab into a Word document, and making graphs and using those frequency tables that will pop up in SPSS as we do the analysis. Okay, so first off, let's select gender as a variable that we're interested in. And let's kind of look at the frequency quickly. So here we see that gender is right here in the database, okay? So first off, if we're going to look at the frequency to do some sort of analysis, we will have to use the analyze function here in SPSS. So go to analyze, and we're looking at descriptive statistics, and we're going to choose frequencies as our option. Okay. So here, what we're going to do is we're going to drag the variable that we're interested in having SPSS count the frequencies for. So we're going to choose gender because that's what is in the lab instructions. So then we're going to click on gender and put it into this box. So on the right hand side here, we have an option for statistics. So if we decide not to click on any statistics, it will automatically give us the frequency of the variable. But if we're interested in getting some more information, we can click on statistics and have some more options so that as we run the frequencies, we can also get different types of information at the same time. So in the lab instructions, she is asking you to also look at deriving the frequencies for male and females, which will already be done because we put it into that frequency box, and also derive a percentage. So she would like you to use that statistics kind of option that we just clicked on, and we can see the percentage of males and females as well in this option. So here we see percentiles, so we can use that option and use 100%. We can also get, as I said, mode would be the most appropriate if we're interested in looking at which gender do we have the most of in this data, so we can run that as well. This is not compulsory for this lab, but it's something interesting for you to click off nonetheless. If we're interested in deriving some kind of charts just for kind of our own personal interest, or if we prefer kind of more visual type of descriptors for frequencies, we can choose a bar chart for frequencies, or a pie chart, or a histogram, okay, which is basically a bar chart but without spaces in between the bars. And then we can also ask for SPSS to give us the percentages. So we can also click that off. So we can go on to, for example, pie chart, and we can ask for frequencies, which we'll already be getting, or we can ask for percentages, which is kind of what we're kind of more interested in looking at. Click continue, and then click OK. So what we are seeing here is in this little statistics box, we're getting N in this case represents how much valid data that we have. Okay, so how many people filled out the gender variable in general. So here we have 2,531 responses. The mode in this case is 2. And if we forget what the 1 and 2 means in terms of males or females, we can see here in our frequency chart that we actually have more females than males. So we know that the 2 actually represents females and the 1 represents males. And then here we have the cumulative percentage. So here we have 50.4% females and 49.6% males in this in this data. And here is the visual representation of the percentages as well. So when it's very close percentages, sometimes graphics aren't that useful. So you can just copy paste this frequency table into your Word document for this lab for now. And then here you'll have your frequencies in this section, and then your percentages in this section. And then we've kind of concluded what you have to do for the first level of set of questions. So now you will have to interpret the frequency and percentage results in simple language. So as I mentioned, that these frequencies are how many males and females you have in the sample, and it comprises this percent of the overall sample size, which is 2,531. Okay. So that was it for the frequency section of the lab. So she said she would like you to label that top part frequencies so that she knows that you knew what you ran. You ran a frequency descriptive analysis on gender. And now we're going to be moving on to our other portion of the lab, and you can title this histogram because we'll be creating a histogram with the variable age. So now we can go ahead and close your kind of graphics after you copy and pasted them onto your Word document. You can close the output, and we will now be moving on to age as our variable. So in here, we're actually going to use a different option, and we're going to go straight to a graphing option in SPSS. So we're not going to be looking at using the analysis function. We could use the analysis function and run it as a histogram because you saw the other option that we had was the bar chart, the pie chart, and the histogram. But she wants you to become a little bit more familiar on how to kind of manipulate graphs and make them look a little bit prettier. So we're going to be using a separate graphing option for this. So in this case, we're going to go into graphs, which is right here, and go into legacy dialogues and into histogram, on the bottom here. And we're going to select age as our variable, and we're going to move the variable over so that SPSS knows that we're using that variable for the histogram, and then select the option display normal curve. So here we have age right here, and we're going to click off this little box, display normal curve. Okay. So here is your histogram, which is basically the equivalent to a bar chart, except that the bars are really close together and there's no spaces between them. And here, this line shows the normal curve distribution, okay? So as you can see, everything is kind of tightly knitted in the middle, but we can kind of see that, there is a lot of people who are close to 60 years old and older, not many people in their mid-30s, as we can see by the frequency here, and then a lot of younger people as well. So we actually kind of have what people would call a bimodal distribution, where there's two typical modes, or two almost separate distributions, you could say, of really young people, not many people in the mid age, and then a lot of older people. So she would like you to edit this graph. So she would like you to kind of alternate the binning so that we don't have too many skinny bars, because it might make it challenging to assess if the variable is distributed normally. So we're going to change the size of our bins, which is basically the size of how this graph is illustrating each kind of frequency. So we're going to double click on one of the bars, and then in the properties box, we're going to click on the binning tab, and then custom, and then we're going to custom bin it in the x-axis, and just kind of change the width of the interval so that we have less intervals, which means that we're going to have less frequency bars, and it's going to encapsulate more people that in kind of like a wider range. So we're going to double click on one of the bars, and properties. We're going to custom for anchor, custom intervals, sorry. And we're going to change this to 0.5 point. Oh. Click apply. And here we go. So here now we don't have that weird bimodal distribution as we saw, because we actually just closed the bins so that people who are in the kind of younger area, they're all kind of bin together, and so that we have this something that looks closer to a normal distribution instead of having that bimodal distribution here. So we didn't change the data, but we kind of just changed how it looked like and how the program was illustrating it so that it's easier for us to interpret if it's a normal distribution or not. So from this new graphic, I would say it looks very similar to a normal distribution, with some people who kind of fall in the extreme left and right side of things, but that's pretty typical. And after you have clicked apply, close the properties box, and you can change the binning however you'd like. So instead of changing it to 5, you can change it to 10, 20, etc. She said kind of choose one that's easiest for you to interpret and then paste it into your Word document, and just use that one. So as she said, interpret this histogram using simple language. Describe whether the distribution is normal, assess the skewness and kurtosis. So if we visually kind of eyeball this distribution, as I mentioned, I'm not seeing any skewness. It's not going in any which direction, like sloping this way or sloping this way. It's most of every data point here is right in smack in the middle, and the curve is not too pointed, which is kurtosis, and it's not too flat, which would give you the opposite issue of kurtosis. So that would be platykurtic. And we don't have any skewness on either end. So I would say this is pretty normally distributed. Okay. So we're actually going to go back into our kind of analysis type of option, and we're going to calculate some measures of central tendency and dispersion and distribution for the variable age. So we're going to do kind of go back a little bit to the option that we were doing with gender, but we're going to do it for age. So here we're going to derive mean, median, mode, range, minimum, maximum variance, standard deviation, and some distribution information. And click continue, and all of these things are going to pop up all in one box for us. So let's do that. So analyze descriptive frequencies. Okay, take gender out, put that back in, and look at age. Here we go. Go back to the option of statistics. And here she would like us to do mean, median, skewness, kurtosis, minimum, maximum, which gives us our range. So the minimum score and the maximum score, which we could really just click off range if we wanted to. It's really the same thing. Variance and standard deviation. I believe that's everything she'd like you to do. And mode. Okay. And click continue and okay. If you'd like, we've already done the histogram for it, but there is also that histogram portion here. Show a normal curve and continue, and then you could see another histogram, but you won't be able to edit it as much as we did through the graphing option. Okay, so here in the statistics for age, we see that there are 2,531 people who filled out that variable, which is the same thing for gender. The mean age is 47.82, so you could see the mean age of the people in the sample is about 48 years old. The median, which is basically the middle of the sample. So if we kind of go into our histogram here, we can say that, age 50 is actually smack in the middle because we have people that are close to age 100 and then people who are in their kind of early 20s or teens. So right smack in the middle would be 50. So that's where we're getting 50 from here in the median of the sample. The mode is 54, which means that most people are 54 years old, even though the average age is 48. Okay, and that's because some people are younger and older, and so the mean is kind of the average. But if you really want to describe kind of where this data could best represent people, it might best represent 54-year-olds rather than 48-year-olds, if that makes sense. Because we know for sure that this age range, or this age in particular, represent most of the people because it's the most frequent age reported in this database. So if you look at age 54, we can see that it comprises 64% of the sample here. And if we look at our histogram, age about 54, we could see that there is really kind of like a huge spike around in the 50s here, so we can see that it's definitely the mode. So here we have standard deviation, which kind of gives us an indication in units of how people's age are varying from the mean. So varying from about 48 years old, okay? So that means most people in the sample are either about 16 years older than that or 16 years younger than that, and that's how much in age units that people are varying in the sample. So that's what the standard deviation really represents. So variance is kind of similar to standard deviation, except that it's not standardized. So the fact that it's not standardized means that we can't it's not an interpretable unit. So whereas standard deviation relates exactly to our sample and to the variable, so we can say that people are either 16.57 units higher or lower in age, and that describes the spread of the sample. Variance is not unique to our data or the variable. It just gives us an idea of the variability in this kind of in this sample. So when we want to talk about really describing the variability, the standard deviation is kind of the best way to go, because it gives us information meaningful to the variable that we can say, people are in this particular sample are varying by 16.5 units in age, which makes a lot more sense for us to talk about concretely. So in terms of skewness, we could see there's a negative symbol, which means that it's slightly negatively skewed, but because it's not anywhere close to our cutoff point for us to say really there is a negative skew, it's just that sign is just kind of telling us it's a little bit closer to the negative side, but it's not something to worry about. So we actually don't have any skewness problems. And in terms of kurtosis here, we can see that there aren't any issues here either. So it didn't surpass our cutoff point, so we don't really have to worry about it being too pointed or too flat of a curve. And here we have our minimum and maximum in our range here. So we know that in this sample for age, in terms of age, that the minimum age is 18 and the highest age is 94. Okay. So what we can do is copy paste this box into your Word document and describe it in typical language of how you could describe your sample. Okay. And then save your PDF file. I don't need your SPSS file at all for this. I just need your Word document with all your SPSS kind of outputs related to the histogram and your frequencies tables and your descriptive statistics table. If you want to add more information, that's fine. It's really up to you. But you're not going to lose marks for not putting above and beyond other kind of illustrations. So if you have any questions, please feel free to email me. If you're having a hard time describing some levels of central tendency in real language, I'm happy to help you.